Hey everyone, welcome to our last session today with hacking Android and iOS apps with Deep Links and XSS. This is with Abraham from 7A Security, so he's gonna start the workshop in a second. Floor is yours.
So can everybody hear me and see me? Yeah, all looking good. Okay, good. So, okay, then let's start. Cool. So thank you for coming. Today's session is about hacking Android and iOS apps with Deep Links and XSS. So this is a free webinar slash workshop, right? It's really a workshop because we have some exercises that you can try on your own. So I sent everybody who registered an invite to the training portal. So when you register and you log in, you will have all the slides and everything that I'm going to use today, as well as by clicking on the links from the slides, you will be able to download all the apps to do the exercise that I will cover in the demos today, right? So yeah, so let's get started. So we're going to talk about hacking Android and iOS apps with Deep Links and XSS. So first, I will give you a brief introduction about this, and then we will talk about deep link attacks, achieving user impersonation and authorization controls, and deep link attacks to make phone calls. And then we will see XSS against mobile apps. And in particular, the scenario of data exfiltration with XSS, right? So how to read local files from the phone and send them to an attacker on both Android and iOS. So I hope you find this entertaining. So I'm Abraham Aranguren. I'm the CEO of 7A Security. If you like this presentation, there's a lot of public pentest reports that you can see on the main website. So if you go to publications, there's a lot of public pentest reports that you can read free. A very fast way to learn about what you should not do when you build your own mobile app. We have delivered training at Black Hat USA, Hack in the Box, OWASP Global AppSec, NullCon, and many others, Hackfest as well. There's some upcoming, for upcoming stuff, you can check the training link. And then a while back, I also wrote a course for e-learn security called Practical Web Defense. So this was about hacking applications and then defending them. I don't make any money out of this anymore, but just to mention that. I'm also one of the leaders of the project leaders of OWASP OWTF, which is an OWASP flagship project. So if you type owtf.org in your browser, that takes you there. For other presentations, you can check my SlideShare and then some certification stuff. So if after all this pandemic we meet someday, I can tell you how this happened over a beer or two. So from the public pentest report, this got a bit more attention. So Smart Sheriff was an application that was mandated in the entire country of South Korea. So by law, parents and children were forced to install this application. So typical political idea of, let's save the children and then things get approved. So in theory, it was a nice idea to, protect the children so that the parent would control, like during what times the child would use the phone and things like this. But in practice, the implementation was really bad. So there was a lot of possible attacks. We tested them twice. So you can see the two public pentest reports. It was so bad that we even gave a talk about it. So you can watch that on YouTube. These are the slides for that. And then another series of interesting pentest reports are the ones for the Chinese government. There's the context of these applications is that there's a Muslim minority in a region of China called Xinjiang, and then the human rights activists were concerned that maybe they are gathering too much information about the citizens. Maybe this would constitute a human rights violation. So we help the human rights activists answer these questions, right? So these are more privacy related, and these are more security related, right? So these are just some of the ones that got a bit more attention on the news, and then there's a lot more pen test reports on the website, right? So this course is also written in part by Anirudh Anand. So he's a security researcher. He's focused on web and mobile application security. He likes to play CTFs, and he's a member of the #1 ranked team in India called Team BIOS. So he's an occasional bug bounty hunter. So he has found in Google, Microsoft, LinkedIn, GitLab, Zendesk, and others. He also likes open source and has contributed to some projects. He has some certifications, and then his blog and his Twitter. So yeah, this is more for the course itself, right? So if somebody plans to take the course, then you need ability to read PDF files, and sometimes people come with a corporate laptop and then they cannot do anything. So that is not ideal, right? So you need USB allowed, ability to at least import VMs and things like this. 8 gigabytes of RAM should be plenty, 60 gigabytes of free disk space, and then for the mobile course, we recommend VirtualBox because we use Genymotion, and Genymotion uses VirtualBox under the hood, so VirtualBox is going to be better this course. And then we will use Burp during the class, but Zappa and Fiddler can also do the job if you are more comfortable with that. And then another thing is that in all courses, right? So normally you are going to get digital copies of training material, lab VMs, test apps, and source code. So the first 4 points are kind of the standard. And then what maybe we do a bit different is we give you lifetime access to the training portal, including all future updates, free step-by-step video recordings, slides and lab PDFs, and unlimited email support, right? We also have Slack, where all the trainees also, get to ask the questions and get answers in more kind of closer to real time, right? So just to mention that. So I'm going to briefly talk about the course, like just for 5 minutes, and then while I do this, I will focus a little bit more on what we're going to cover today, right? So the first part talks about hacking Android and IoT apps by example. So we start with using Termux and try to understand how permissions work in Android. So we do a general setup check and all this. So we are not going to do any of this today, but just mention this. And then in Lab 2, we talk about reversing and source code analysis. So here we will do some of this stuff today. In that we will look at the Android manifest a little bit. And then we also check like some automated tools like Quark and Mobile and others, right? Then in Lab 3, attacking Android apps. So this is some of these is what we're going to cover today. So today we will do a little bit of Drowser. In particular, we will exploit deep links with Drowser. So we will see a little bit of this. And we will also see deep links in Android. We will do the demo for Periscope. But in the course, we also have another one for Shopify with a nice fingerprint bypass. So this, just to mention that the course, like you have some applications, and in the workshop today, we will also use this Periscope cross-site request forgery with deep links. This will be one of the demos today. And then with web views and data exfiltration, we will do a little bit of this today, not the whole thing because we don't have time, but a little bit, so that you see how this works, right? With XSS and data exfiltration and attacking web views and all this. Then Lab 4, Art of Man in the Middle. We won't do this today, but just to mention this. And then we also check repackaging Android apps, so modifying the applications at rest and all this stuff like bypassing detection and doing other things. And then in Lab 6, we talk about instrumentation, expose, bypassing pinning, monitoring the application on runtime, and other very cool things. Then each day ends with a CTF with open challenges for you to practice. And then in part 2, we talk about hacking iOS and apps by example. So we start with an introduction, how to install apps, download stuff from the broken phone, and other things like this. And then, yeah, here we will talk about decompiling, black box analysis, and so on, but today we are not going to check this. And in lab 3, we will do some of these today, right? So we will do attacking web views and data exfiltration, and then finding and exploiting URL handlers, right? So these are the two things. So just to mention that what I'm going to show you today is a very small part of the full course is about, but just so that you have a little bit of background about where the things we're going to cover today, where they fall in the course, right? Then there's man in the middle for iOS, like what is different and how to bypass pinning and do other things like this with man in the middle, modifying IPA files as REST. So we will patch binaries and other things. Also, when you patch an application, because in iOS things tend to be a binary, but sometimes you have an application written in JavaScript. You might not need to modify the binary. You can modify just the JavaScript file. So we have some examples of that as well. And then we check instrumentation. We also check out different things here, bypassing jailbreak detection using Cydia tweaks, introduction to Ccrypt, introduction to Flex. Flex is a really cool tool that allows you to do a lot of stuff from the phone. And then we also cover passion fruit, right? And then at the end, again, open talent. So that is just a very quick overview about what the course is about. And today we're going to see some small parts of it. So with this, now we're getting started with the actual webinar/workshop. So does cross-site request forgery exist in mobile apps? What do you think? Chat. Yes, is this a yes from, can you hear me, or is this a yes from cross-site request forgery exists in mobile apps? So anybody? Seems, yeah, on the stream it seems it's one slide behind of where I am. So yeah, what do you think? Cross-site request forgery on mobile apps? Yes, no? It was at the beginning, yes. Yes, I think so, exactly. So yes, so cross-site request forgery exists in mobile apps, right? So yeah, we're going to see this in this section now. So we're going to cover deep link attacks, achieving user impersonation, and deep link attacks to bypass authorization controls. Right. So first we have to talk a little bit about the basics, right? So introduction to mobile deep links. So deep links are URIs that can be used to navigate to different parts of an application. They are available on both Android and iOS. Then deep links can have, do not have to have custom schemes, right? So I'll explain this in a moment. So for example, a social media application could register a custom URL scheme like social app and then : / homepage. So this would be a custom scheme, this social app, right? So any click to such a link will be automatically directed to this application. So this provides the ability to navigate to different activities and pages. So we can have social app : / profile. And this we could open the profile on there. Then we could also have social app and then : / profile pic. And then this will allow us to access the profile picture within the profile page. So when we are looking at the Android manifest, browsable is interesting, but it is not necessary for this kind of. Right? So we have an activity. So this starts with the activity tag on the Android manifest, and then we will have the name of the activity, and then You can see here there's no exported true, right? So this is because the activity is not explicitly exported, so it doesn't have exported true here, but it has intent filter. So the intent filter of the of this activity implicitly exports this activity to other apps on the phone, right? So even if you don't see any exported here, if there's an intent filter, this means that any app installed on the phone can call this activity and try to attack it. So in this case, we have Android scheme of some app. Then the host part of the URL is called getcreds, and then the path prefix is /user, right? So this means that we have to build a URL like this: scheme : / host and path. So in this case, it would be some app and then : / getcreds and then /user, right? So this would be a way to call this deep link. And then if we also have this browsable thing, which is optional, but when it is present, it makes the attack more interesting because sometimes we can also exploit these issues from a browser, right? So if you use the browsable category for an activity, this means the activity can also be invoked from the Android browser, right? So this can be interesting as well, right? So with this, we will start with a case study with a Periscope cross-site request forgery using deep links. So for everybody who registered, I send you an invite to the training portal. So when you log in and you download the slides, while you are still logged in, from the slides, just click on this link, and then this will download the vulnerable Periscope version. So if you use the latest, it won't work because this was patched. You need this exact same version, right? So not any version of Periscope will work for this. You need this exact version that you can get from the training portal, right? So if anybody has problems, just send an email or something, and we will troubleshoot them, right? So email admin@7security.com, and we can either give you access or help you troubleshoot if you have any problems. And then I'll mention this at the end as well, but you can also get this workshop and other workshops for free on the store. So that's something else as well. So if you go to store.7security.com, you can get this workshop and other workshops that are also there. There's a much longer version of this that is almost 4 hours. That is also about mobile apps as well, and it has like the same demos as here, but then in the middle there's a lot of slides covering a lot of other different attacks. So you can also find that interesting, right? So download the slides, and then you click on this, and then this will download the vulnerable version of Periscope, and then you can install this in some Android phone or Genymotion or any Android emulator, and then you can try this exercise, right? So I'm explaining this because I will do the demo afterwards, but as you follow along, it will make things a little easier. So one thing, after you install the Periscope, you will need to create an account, of course, because to demonstrate the deep link issue, you need to have an account first, right? Otherwise, when you open the deep link, it will just open where you don't have an account yet, so you'll be able to see that this works, right? So just click on create new account, and then you can create it in Google, Facebook, Twitter, phone number. That's your choice. It doesn't really matter. You can use whatever you want. And then after this is created, then you're ready to start doing this, right? So one thing would be to look at for cross-site request forgery issues or deep link issues in Android applications. First, we need to decompile the application and take a look at the Android manifest, and then from there, take a look at the activities as well to try to, find some potential problems here, right? So the main thing that we are looking for are scenarios where a malicious attacker could trick a user to follow arbitrary accounts without the user consent using deep links or something similar like that, right? So some sort of a deep link that performs an action without any user confirmation, right? So if you have a scenario like that, then it may be possible to get a cross-site request forgery. So the first thing we need to do is to decompile the application. So you can do that with APK tool. So if you do APK tool and then D for decompile and then the Periscope APK, this will decompile the APK. And then from there, you will be able to, investigate the problem, right? So when you run APK tool, this will look something like this. You see an APK tool, blah, blah, blah. Then you will come output like this. And then we can start looking at the Android manifest, right? So you open the Android manifest.xml, and then you basically have to look for these intent filters, right? So you see like action and then category, browsable. And then here you have like the data, Android host, Android path prefix, Android scheme. So this is showing you how the deep link structure is, right? So I mentioned before that deep links can have custom schemes, but do not really have to have custom schemes. This is a scenario where we can see that, right? So in this case, we have an Android scheme of HTTPS, an Android host of www.periscope.tv, then a path prefix of /. So this means if you have like HTTPS : / and then www.periscope.tv / then this activity, the activity that has this intent filter, will be invoked, right? So the same way that we use attack deep links using custom schemes, we can also attack the applications using HTTPS links, as long as the application has registered these links on the activity itself, right? And then you will see there's a lot more possible combinations. In this particular case, we will focus on the host, the user, the path prefix /, and then the scheme is PSCP. But this same attack is also possible with other combinations here, right? So here the deep link has the scheme PSCP, so you can see that here Android scheme PSCP and the user is the host. So this means the deep link is going to be PSCP : / user, right? So that is how it is. So this means that there could be a parameter passed to this deep link, which could be the Periscope user ID. So the user ID is a unique identifier for any given user or profile Periscope, right? So for this demo, we will use these particular users, right? So PSCP : / user, and then MKBHD. So this is just one guy in Periscope. And then we have several ways to test this, right? One way would be to use another application to demonstrate. So for this, you can use Deep Link Tester. You can also get this from the training portal. So as you log in, just click on this and just download it and install it on your Android phone. You can test it there. I'll demo this as well. And then you go to Deep Link Tester. And then in here you have PSCP : / user, and then the user ID. And then when you click on go to URI, it will open the guy on Periscope, right? So this is basically just opening the profile. So we are still not doing any damage here. I mean, it could still be annoying for pranking purposes, but nothing very serious, right? We are not following the person automatically. We can also do this with an IDB command. So we can do IDB shell and then Android intent action view, and then with data of the intent being deep link. So PSCP : / user MKBHC. And then this will also open the profile. And then we can also do this from Drowser, right? So Drowser is basically an application that simulates a malicious application on the phone. And then from the computer, you connect to this Drowser agent and you can run commands, right? So I will demonstrate this as well. One thing that you might want to do is to run the scanner. So Drowser has this scanner that you can run. So you can run scanner activity browsable -a and then tv-periscope.android. So this will scan the application for browsable activities. Now you can see that this is only checking for browsable activities and not all activities with deep links, right? But still, it can be interesting or a good start. You will also notice that the browser finds a lot less combinations that are actually present on the application. But again, this can still be a good starting point. Just don't rely on these for comprehensiveness, because this is not comprehensive, right? Nothing beats a human with brain. So yeah, this is not perfect, but it can sometimes save you a little bit of time or point you in the right direction. So with this, we can then do like run app activity start and then /action Android intent action view, and then data URI pscp :/user kbhd, and then this will launch the profile as well. Now, because the activity is browsable, we can also do this from this link, right? So if you open this link from your browser, then you click on open user, this will open the profile as well, right? So you need to do ADB shell and then Android intent action view, and then you can pass the URL like this using ADB, and then this will open it in the browser, unless you want to type this Android phone, which is also fine. You can also copy paste from the computer into the phone if you are using Genymotion or something. So this is how this will look like, right? So you can click on open user, and this will open the user. So 4 different ways of doing the same thing, just invoking the deep link, right? So deep link tester, so malicious application on the phone with ADB, and then we check with browser, and now we're checking with the browser as well, right? So this is just opening the profile, and then to actually follow the user, we have to add /follow at the end of this, but it's basically the same thing. Of course, you need to unfollow first to, be sure that this is working. So you have this user nkbhd/follow, and then go to URI, and you will notice that you start following the guy. And then if you do it with ADB and then /follow at the end, this will also follow the guy. And then if you do it from browser, it's again the same thing with the /follow. And then from the HTML page, it is the same thing, but in this case, we will click on Periscope cross-request forgery demo, and then you will see that we follow this person as well, right? So the HTML of this proof of concept page looks like this. So pscp :/user mkbhd, and then so this is just opening the user. What you can see is basically just a link containing the deep link, and then Android knows that this deep link has been registered by an app on the phone, and it will open the app on the phone, sending it the deep link, right? And then when we do it with the /follow, then it will open the, it will follow any user we want automatically, right? So yeah. So how could this work in practice? Like an attacker could, embed a deep link on a web page or an ad, and then the visitors would be tricked to follow a profile that the attacker sets, right? So instead of Periscope cross-request forgery demo, in a real attack, this would say something like win an iPad now. Then when the user clicks on it, it will automatically follow the user. Right, so for ease of access, you have these links, so you can click on this, open this on your Android phone, and you can click the link from there. So yeah, so how to fix this? To fix deep link issues, you basically need to prompt the user for some confirmation, right? So you want deep links because they make functionality more useful to users, but you should also request user confirmation before performing an action. So in this case, it would be like, do you really want to follow this user? And then the user tells you yes or no. Then depending on what the user says, you follow the user or you don't, right? So that would be a valid mitigation for this kind of issues. So with this, let's do the demo. So let me see Yeah, you can see my whole screen, so I think you will be able to see this. So, okay, so yeah, so this is the Genymotion VM that we will use to demonstrate this issue. This is the Periscope application. So you can see, okay, Periscope is discontinuing. I didn't know this. So, okay, so this is the application. And now what we're going to do is first demonstrate with Deep Link Tester, right? So if I go to URI here, Deep Link Tester, you can see that we are opening the profile of this guy, right? We are not following yet. And then if I, well, let's look at the Android manifest, right? So when you look at the Android manifest, you look for intent filter, and these will show you which activities have some intent filter. So here you can see this is a browsable activity, and I can keep looking for intent filters. You can see some of the intent filters have Android schemes of HTTP, HTTPS, while others have this PSCP. So here we have this PSCP user, and so on, right? So methodology-wise, you would look at the Android manifest, you would look for intent filters, and then you would go back up to the activity itself. So you would go to, okay, so this is the actual activity, and then you would do something like find the activity.java, for example, and then you will open this and start analyzing the code, right? So in this case, this abort the activity, extends launch activity. So you would search for this launch activity, and then you would start to go through this code and figure out, if there's any deep link issues, right? So I'm keeping that part a little bit, but that is more or less how. Of course, the decompiled code is not going to be as pretty as the developer's code, but it can still be enough in most cases to get the job done, right? So that is how you will go about it methodology-wise. And then to show ADB. So if I do ADB shell and then start Android intent action view, then I'm sending as data PSCP user and the ID of the user. So you can see it open the user here. I'm going to do it again. Now that I closed it, you can see that we opened it, right? And then with Trotter, first you would run there's no syntax for this. So you would first run the scanner, right? So you run scanner activity browsable. So this will scan for browsable activities, and this is the output. It will tell the invocable URIs and so on. And then you pass it the ID of the app. So this would be the package name in the Android manifest, right? So if I go here, Android manifest.xml, and I open this one from you can see that is in the package, right? So it's going to be at the top of the manifest, the package. So this is what we have to pass to Drosser here to the scanner to find the activities, right? So this is, to try to find some deep links. Now, again, don't rely on this 100% because you're going to miss stuff, but it can be a good starting point. And then let's first make sure the profile is not open, right? So it's not open now. And now I hit it with Drosser, and you can see that we open the profile. For this to work, you need to have Drosser installed, and you need to open Drosser on the phone and make sure that you connect your computer to Drosser. Now, on the course, of course, we go into more detail and step by step on how to do this, and it's also a VM already set up. But now for the quick workshop, we don't have time for all that. So that is just basically how it works, right? So when we use this command from the browser, this opens the user, and then we can do the same thing from the Android browser, because the activity is browsable. So I can click on open user, and this again opens the user, right? So I'm just going to close it, and then going back to the Android browser. And then when I click on open user, you can see that the profile is being opened, right? So now let's do the same thing with the follow. So now if I add here /follow from Deep Link tester, you can see that this changed to following, right? So we're not following this person, but this means that any app can send an intent to this application, and then it will follow like arbitrary people on the internet, right? Whoever you tell it to follow, it will follow, right? So this is the problem. So that is the demo from Deep Link tester. We can do the same, adding the /follow from ADB. So you can see that we're following. Now I'm going to unfollow again, right? So not following, and now we can do it from browser. So I add here the /follow, and you can see from browser it works as well. So now I'm going to unfollow, and now we can do it from the browser, right? So following. So I'm going to unfollow again, and now I'm going to here to the browser and do the cursor request forgery demo again, so you can see that we are following the guy, right? So this is the cursor request forgery with Deep Links Android. So yeah, you can follow these steps from the training portal. Just download the apps and play with this, and yeah, and I hope you find you have fun with this one. The one for Shopify, that's in the course. There's also a lot of other cool exercises in the course, but the one for Shopify we won't have time today. It's also very cool because it's a function that requires a fingerprint. It requires the user to enter the fingerprint to log in, but using a deep link, we can bypass the fingerprint check, right? So that's pretty cool. Okay, so now we're going to check deep link attacks to make phone calls, which is an abbreviated version of finding and exploiting URL handlers in iOS. So we have an iOS phone here to illustrate this. So I hope you find this entertaining. Now again, just download the app from the training portal. Just click on this because we don't know, from third-party websites if they will change the app, or maybe it will work the same way or not. So the safest is to use the one from the portal. That's the one we're sure it will work fine. So yeah, we will use the vulnerable insecure app version 2 for this. And then here, methodology-wise, instead of looking at the Android manifest in iOS, we are going to look at the info plist. So in particular, we're looking for CF bundle URL schemes, and then we will look for which URL schemes are there, right? So in this case, you will see these two URL schemes like dump vulnerable insecure app and dump vulnerable insecure app Swift. And both URL schemes will work, right? So you can unzip the IPA and try to look at the info plist like this, but chances are this will be binary garbage unless you have a Mac. But I will show you a trick to look at the info plist using I'll show you that during the day, right? So that's another way. If you don't have a Mac, it's another way in which you can check the info plist. So if you have a Mac and you have Xcode, now, if you don't have a Mac, you can Google, how to run a Mac from Windows or how to run a Mac from Linux. And there's a lot of tutorials about that. Be careful. I'm not sure how legal that is, but just saying it's possible. Right? So you don't necessarily have to have a Mac to use Xcode, all these things. So using Xcode, because Xcode only runs on Macs, right? But you can, there's ways to get a Mac VM running. So when you open Xcode, you will click on the project for Dumb Vulnerable and Secure version 2, which is public. So check it there. And then you can click on this and then go to the info tab. Then you scroll down to the bottom to URL types. And here, this also shows you the URL schemes, right? So we can see here there's 2 custom URL schemes, Dumb Vulnerable Insecure App and Dumb Vulnerable Insecure. So that's the way to find them with Xcode. I'll show you the method with filter in the demo. So this means that Dumb Vulnerable Insecure App Swift // and Dumb Vulnerable Insecure // these URLs will be opened by this app, right? So what can we do with this? We will need to look at the source code and try to see if there's any vulnerability in the processing of the arguments, if there's some SQL injection, some other form of injection, cross-site request forgery, or some other dangerous thing being done by the application when it opens a URL like this, right? So if you don't have Xcode, file to look for is appdelegate.swift. Now, most of the time, iOS applications now are written in Swift. Before, they used to be written in Objective-C. So if you find if the application you're testing is written for some reason in Objective-C, then this, instead of being .swift, it will be .m. So the M is the extension for Objective-C files. .swift is the extension for Swift files, which is the modern way to write iOS applications, right? So, but in both cases, it's the app delegate that you're looking for. So you find .name and app delegate.swift, and that will point you to where that file is. And then you just take a look there and try to find in this case, we have the function application, open URL with the URL parameter. And then here we can see that this is splitting the URL by a string called /phone/call number. So it's taking the URL and splitting it based on this, right? So what this is doing is similar to explode in PHP. So this is taking the URL, and then the chunk before this string will be on the 0 position of the array. Then whatever comes after the call number, this will be in position 1 of the array, right? So this means that this check here is checking the number that comes after this, because the array starts with 0, so 1 is what comes after, not before. So URL 1 means the second chunk, which is whatever comes after the call number, and then this is casting whatever value is there to integer and checking that the casting works, right? So the casting is different than nil, then it assumes that this is safe, and then it tries to make a phone call. Right, so this is basically how this works. And then using Xcode, you will go to app delegate Swift, and then function application, and then split URL, and here you can see the same string, and then this is casting to integer and so on, right? So that's how that looks. So this means that the application appears to have URLs like the following, and it will ring the number without further user prompts or confirmation, right? So it's looking for URLs like this: vulnerable, insecure app, Swift, ://phone call number, and the number, or the same thing with insecure app ://, right? So you can open in your phone this URL to test this, and then you can practice the exercise. For this particular exercise, it will work even if you don't have a jailbroken device. So yeah. It's not necessary to have a jailbroken device to do this exercise actually. So yeah, and this is how the HTML looks like. So you have basically the URL, and then of course this would say win an iPad or click here to win the lottery, or whatever, something like this, enticing to the user. And then the actual exploitation will look something like this. So in Safari, you click on some of the links, and then you have this opening down below, version 2, and then you tap on open, and then you can see that the phone call is being made, right? So yeah, this shows you that the ability to make an app ring arbitrary phone numbers is a serious issue in the mobile environment due to the possibility of making the app numbers. Hence, the attacker can monetize the attack. So let's do a demo of this. So here we have the iOS, an iOS phone. So I'm going to show you first how to look for the info pillars, right? So you would tap here first on the list of applications on Filza, and then I will scroll down to the vulnerable version 2. So I tap on the I for information, and then I go to the bundle directory. And here, I'm sorry, I'm going fast with this, but there's a lot more coming. So yeah, and then on the info list, you just scroll down. Here you can see that it understands the format. And here you can see that these are URL handlers, right? Download Swift in the bundle URL schemes, right? So I'm showing you these from Fields on the phone because if you check it if you just unread the IPA file, you can get into something like this, right? So you can see here that all this is like a binary format that BI doesn't really understand. So it's kind of messy to make any sense of this. So you can open plist files natively in Mac. You can check the iOS files using Filza on an iOS device. And you can also use a tool called PLUtil that allows you to work with plist files from the command line. So with that out of the way, now we can go to actually tapping on the URL handlers. So I'm opening here the first handler, and you can see that it makes the phone call. And now I'm going to open the second one, and I tap on open, and you can see that it makes the phone call, right? So yeah, so that is the end of that. So now let's talk about XSS and data exfiltration on Android and iOS. So let's talk about web views and data exfiltration on iOS. So basically, web views are a small web browser in your app. And then here we can have several scenarios. We can have HTML detection, XSS, data exfiltration of local files, and then possibly user impersonation using cross-request forgery via XSS. So for this, we will use a customized version of Android Go. So if you use the official Android Go, this won't work. So again, you need to, once you get access to the portal, which is all free, you can click on this link to download the Android Go version that has been improved for this particular exercise. And then you install this, and you will be able to follow the exercise, but it's important to use this one from the training portal, especially in this case, right? So in this case, we have to go to insecure data storage and then go to share preferences and add some files, right? So you create XML file, my secret user and the password, and hit save. Then we have to do the same with SQLite file, SQLite, my user, my password. And then we navigate to the exercise, so input validations and input validation XSS. And then here we can try to check for HTML injection. We can check, image source action or alert1, script alert1 to confirm. So with the HTML injection, we saw a bigger hello because we use H1 text. So that confirms we have HTML injection. Then we have to check if we have XSS, which we can do with one and so on. So we can try this and we can see that we get the alert. And then we can see, okay, we have XSS, what is the location? Because the location can tell us if it's a more privileged location. For example, a file URL will not be subject to the same origin policy, especially if some of the settings in the web view are insecure, right? So in this case, you can see this using file URLs. So this is insecure. And then we have two scenarios, one with internal storage and another with external storage, right? So external storage, other applications on the phone could write to this. So you don't even need to have XSS. As long as you are loading HTML from the SD card, other applications could modify this HTML and attack it, right? So for data exfiltration, we need to figure out the path. So if you're using a simulator or Genymotion, you already have root, so you can do ADB shell and then navigate to the application, do a find, and then see the data files are this. So the user's XML and the AGOT for the SQLite, right? And then once we know that, we know the full URL of the file that we want to steal using XSS, so we can do a new XML HTTP request of the path, and then we send this request, and then we alert it to demonstrate that we can read the file. Right, so we will do this with several files, and this is how this will look. Yeah, and this is, and then if the application has SD card access, then any application that any file that the application can read from the SD card is something that you could steal with the XSS. Then if there's other files on the phone that have permissions that allow the applications to read them, then this will also, be possible to be stolen with XSS with data exfiltration. So this is an example of reading a configuration file from the phone or reading a file from the browser, which has permissions that allow other apps to read it. So it's just a demonstration, right? So we can do all this, and methodology-wise, you're looking first, like we have XSS, what is the location, so in what context does this run, and then can we steal local files, right? So that is basically what we look for. And then with the SD card manipulation, we can do an ADB pool of, so we can find where the file is on the SD card, and then we can do an ADB pool of this HTML file, modify the file locally on our computer, and then we do ADB push of the HTML file into the phone, and then we can add here the payload, like to read the file, and then we will be alerted as soon as the exercise is open, right? So then when you click on input validations, you will get this alert immediately, right? So for root cause analysis, you can this, so I'll just skip this because we're a little bit behind. So in this case, it's because it's a DOM XSS, because it's using DOM write using user input. So it's a DOM XSS in the HTML using DOM write, and then you can like do things to drill a little bit deeper, and then see how you have these set JavaScript enabled to true, set allow universal access from file URLs to true, set allow file access from file URLs to true, set allow file access to true, and so on, right? So all the insecure settings are pretty much enabled. This is why this works, as well as because this is loaded from a file URL. So to mitigate this, if possible, use text views instead of web views, because XSS is not possible with text views. If you must use web views, disable as many settings as possible, especially JavaScript, all file access options, and any other not strictly required functionality, right? So as in network security, you want to close as much as possible, right? And then leave the minimum settings possible for the application to work. Output encode user input prior to rendering it in any web view, and then avoid DOM XSS things as much as possible. Or at least sanitize user input prior to assigning it to a DOM XSS sync, like inner HTML, location, href, and so on. So the OWASP XSS prevention cheat sheet has a lot more details on this. So with this, let's do a quick demo of this. So first, I have to go to Android, and here we will go to insecure data storage, share preferences part 1. And here I'm going to put my username and my password. And I'm going to hit save. And then after we have saved this, we can go to SQLite and do my SQLite user, my SQLite password, hit save. And then with this, what we have done is create the XML and the SQLite files. And now we can go to input validations, XSS. And here I'm just going to try all the payloads at once, which will be a little bit faster. And then I'll explain it as we go. So yeah, I think that should be enough. So if I go back to the application, let's see, application. So if I paste this, you can see this is the alert 1. This is the alert location, so we can see, that this is a file URL, so it's potentially insecure, trouble. And then this is the username and the password. So we can read the credentials from the XML file using the XSS. So you can see my username and my password from the XML file using XSS. And then these are the credentials from the SQLite database. You can see my SQLite user, my SQLite password, are the credentials that are readable from the XSS, right? So this is another alert. Then this is the file from the browser, so we can read also other files on the phone as long as the permissions allow the app to read it. Yeah, and that's basically it. So with this, let's try to rush a little bit through web views on iOS. So basically it's the same thing, but I'll show it on the demo directly. But in this case, instead of file URLs, you could face Apple Web Data. So this is basically another possible equivalent to file, right? In Android, you can also have, in iOS, you can also have file URLs, but you can have Apple Web Data is kind of equivalent. It means out of hope concentration, and then you can retrieve all files. Methodology-wise, is basically the same thing: alert 1, alert location, and then try to read files from the phone history, phone call history, things like this. And then for the root cause, you're looking for WK web views and UI web views. It's possible on both, but the UI web view is kind of weaker by default. So in UI web views, actually by default, this XSS, you have much higher chances of damage. Then this is a string concatenation in Swift, which is a little bit weird because you have the backslash and then the name here. And then this is how it looks like from Xcode, right? So you have load HTML string of hello and then the name. So this is the vulnerability. You can see that Xcode understands Swift because it's showing the name in a different color than the hello. So this means that this is a string concatenation and it's a little bit easier to see on Xcode. Then, because the base URL is nil, this means it's being loaded from Apple Web Data, which means that the application is vulnerable to data exfiltration as well because it's using a UI web view without a URL. And therefore, we don't have the same origin policy, right? So we can read local files and we can send them to arbitrary third-party websites. So in general, UI WebView is much more insecure because by default it has this WebKit allow universal access from file URLs and WebKit allow file access from file URLs. And these two insecure settings are disabled by default on WK WebView, which is faster, is the new way of doing things, and safer by default. And also in UI web views, you cannot turn off JavaScript entirely. Well, in WK web views, you can, right? So in general, try to use WK web views for mitigation purposes. And if you have a UI web view and you have XSS, chances are you can do more damage. So with this, let me do the demo pretty quickly, and then we can wrap up. And we are more or less on time. So in here, we have to go to web view issues, and then start challenge. And I'm going to open, I'm going to try all the payloads once, which will save us time. Then I can explain what this is about. So I go here, and you paste the payloads in this. And now we start getting the alerts, right? So now, because JavaScript is asynchronous, you won't get the alerts in the same order if you do this. But you can see here we have the alert of location showing us Apple Web Data. So this is where we get excited because there's potential for stealing local files. This is the alert one, which confirms the XSS. This is reading the phone call history from the phone using XSS. And yeah, this is another SQLite database from the phone. And yeah, and this is pretty much it. So this proves that, with XSS, you can also steal local files. So if there's any questions, now is the time. And then before I start answering questions, just to mention that if you go to store.7asecurity.com, you can get this workshop as well as other workshops. So this one is only 1 hour. There's another one called Practical Mobile App Attacks by Example, and that is almost 4 hours. So it has a lot more examples, goes into these scenarios a little bit, with a little bit more time. So if this was a little bit fast, I think you will like that one as well. And then there's a lot more attacks from real pen test on that one. So I think you will like that. And then just to mention as well, there's a discount on the store. If you are interested on any of the courses, there's 25% off. So if you use the NY for New Year 25, you can use that. So with that, let me check if there's any questions. I'll leave this for sure. Could you give us an example how this could be exploited without the browsable property? So yes, without the browsable property on Android, I showed the ADB command, the deep links, so the deep link tester. So these would all be ways. This is the question. So these would all be ways in which that I showed during the demo, right? So these would all be ways in which you can do this, right? So if I go here, user follow with deep link tester, so this is going to work without browsable because this is an application installed on the phone, right? So with deep link tester, with ADB, yeah. So browsable is just for the attack from the browser itself. Maybe share slides only because these might get a little bit messy. Okay, so yeah, okay. So I think I answered that. If I understood correctly, without browsable, we would need a malicious app on the victim's phone to exploit. Yes, so that is correct. Yeah, okay, so I think that's the only question. So any other questions?
Seems we're good. Anyone else?
If there's no more questions, or if you have any questions, if you are shy, you don't want to ask the question in the chat, you can send an email, to admin@cybersecurity.com, and we will do our best to answer as well. I hope you found this interesting. And yeah, there's a lot of other workshops that you can get like this for free on the store, right? So it's not just about the paid stuff. You can also get some free stuff. So cool. So then maybe we wrap it here, or we like 1 more minute if somebody has a question.
Hey, thanks everyone. Thanks for joining Hackfest Holiday. Hope you have a good time.
So it seems there's no more questions. So thank you everybody for coming, and I hope you you enjoyed this.
Thanks a lot, Abraham.
And yeah, if some of the people watching on YouTube didn't get access to the workshop, you can get access yourself on the store, or if you prefer, you can send an email to admin@7security.com and we can give you access for free. So yeah, that's also
Thanks again.
The store will be faster because it's automated, so maybe, you know, while we're sleeping or something, because of different time zones, you know, people will be able to get it.
Right.
Awesome. So yeah, let's leave it here. Thank you again, everybody, and Happy New Year.
Thanks all. Have a good one.